Imagine you got up late and had no time to take a shower. You just threw on the first thing you could find, so you left home with mismatched socks, but you still missed the school bus. You had to call an Uber, but it's super expensive because it's morning rush hour, and you were trying to save some money to take your girlfriend on a nice place for dinner this upcoming weekend. Then, when you get to school, your girlfriend says she wants to take a break because you look nasty today. Believe it or not, even though all those things suck, and you only have negative feelings because of them, this is actually a positive feedback effect. Similarly, that is what's happening on our planet Earth today. We humans have been emitting tons and tons of greenhouse gases to the atmosphere. Take that as you getting up late. That's the trigger of everything. Because of the greenhouse effect, our Earth's climate system warms up, and you can take that as you're feeling terrible to level 1. Then, as the temperature increases, the atmosphere will absorb more water vapor, and the hydrological cycle gets enhanced. As water vapor itself is an important greenhouse gas, it strengthens the warming. That is like when you miss the school bus and you have to pay a lot of money for a ride and your feeling terrible reaches level 2. In the meantime, because the sea surface temperature grows, ice sheets and snow covers start to melt, and that decreases the Earth's surface albedo and helps Earth to absorb even more energy than before. That will even warm the planet more. And that is how your girlfriend broke up with you and your feeling terrible reaches level 3. The current state of the climate is based on the latest report from the IPCC in August 2021. The IPCC is the Intergovernmental Panel on Climate Change, which is the United Nations body for assessing the science related to climate change, its implications, and potential future risks. Based on the most up-to-date understanding of the physical climate, humans, through the emission of greenhouse gases, have caused the warming of the Earth's atmosphere, ocean, and land. Greenhouse gases, including carbon dioxide, methane, and even water vapor, are responsible for global warming through their absorption of infrared radiation. Well-mixed greenhouse gases have increased in concentration due to human activities dating back to 1750. In the last 3 decades, concentrations have continued to increase by 47% in 2020 as compared to 1990 emissions. It has been warmest in the last 4 decades compared to any decade since 1850. The net warming is due to greenhouse gases. An increase of global surface temperature from 0.8 to 1.3 degrees Celsius in the 19th century to the last decade is attributed to humans. Not only are there rapid and widespread changes in temperature, there have been changes observed in the atmosphere, ocean, cryosphere, and biosphere. These changes have been found to be distinct from natural cycles and are most likely due to human sources. The most prevalent changes have been in sea level rise, Arctic sea ice extent, precipitation, and ocean heat content. The global mean sea level has risen about 0.2 meters between 1901 and 2018. There's been a global retreat of glaciers starting back in the 1990s. There's been a decrease in Arctic sea ice extent between the periods of 1979 to 1988, as well as 2010 to 2019. There's been an increase in global precipitation over land since the 1950s. And finally, there's been a global upper ocean warming since the 1970s. And all of these factors are likely due to humans. We haven't seen the changes that we're seeing now in the past centuries to thousands of years. Due to climate change, extreme weather and climate effects are already being felt worldwide. Heat waves over land regions have increased since the 1950s and are concurrent with droughts. Heavy precipitation over land has become more frequent and stronger since the 1950s. Strong tropical cyclones have increased in number, and the location of their peak intensity has shifted northward. The effect is greatest in particular regions of the world, such as the poles and the equator, where precipitation is the most impacted. Evidence of these extreme changes have continued to increase since the last IPCC report and are linked to humans. Although there do remain some uncertainties, especially, for example, understanding aerosols and their effect on the radiative budget, global warming is a reality we have to contend with. And the excess energy due to the warming is of course being stored within the Earth's system. 91% of this heat is stored in the oceans, and the rest is causing land warming, ice loss, and atmospheric warming. The estimated increase in temperature is 3 degrees for every doubling of atmospheric carbon dioxide concentration and is a major cause for concern. While human activity is most likely accelerating climate change, humans are also the ones most affected by the impacts of climate change. Concurrent and repeated climate hazards occur in all regions, increasing impacts and risks to health, ecosystems, infrastructure, livelihood, and food. Multiple risks interact, generating new sources of vulnerability to climate hazards, compounding overall risk. These interacting impacts will increase food prices, reduce household incomes, and lead to health risks of malnutrition and climate-related mortality with low to no levels of adaptation all around the world, and particularly in tropical regions. The newest IPCC report gives predictions based on different scenarios. The higher the number, the less efforts we put on controlling emissions and the worse situation we'll find ourselves in.
Now, the IPCC 6 report suggests that people reduce or completely stop using fossil fuels. Why is that the case? Fossil fuels are one of the vital energy sources for everyday life. You need gas for cars, and industries need power to make products. However, fossil fuel combustion leads to greenhouse gases, such as carbon dioxide and methane. Scientists use various methods to track where the carbon dioxide emissions come from, and they discovered that fossil fuels are one of the primary sources of this carbon dioxide. Now, as we previously mentioned, fossil fuels are mainly used in industries and transportation. What can we do about that as individuals? Well, there are many things we can do to reduce the use of fossil fuels. For example, using electric vehicles instead of traditional gasoline cars can be one way to decrease the amount of fossil fuels used. Also, a carbon tax can be used to make carbon more expensive to emit and therefore control the amount of carbon emitted. Companies would have to reduce carbon emissions by shifting to new energy sources. Therefore, supporting companies using renewable energy can be a good thing you can do as a consumer. Buying products from environmentally friendly companies can signal to the market that renewable energy is more profitable and therefore reduce the amount of fossil fuels used. A carbon footprint describes the amount of greenhouse gases emitted by someone in a given year. This can be a tricky calculation because each greenhouse gas exerts a different amount of warming in the atmosphere. Carbon footprint makes sure to account for these differences by converting each unit of greenhouse gas into the amount of carbon dioxide it would take to achieve the same warming effect. Using this method, the average American has a carbon footprint of about 16 tons of carbon dioxide emitted per year, according to the Nature Conservancy. You can calculate your own carbon footprint using this handy calculator. There are a lot of different factors that you can adjust to become more environmentally friendly and shrink your footprint. One way to monitor the carbon footprint of the world is by using the En-ROADS Climate Solution Simulator tool developed by climate experts from the Climate Interactive and MIT Sustainability Initiative. Based on En-ROADS results, the current scenario projects that temperatures will increase by 3.6 degrees Celsius by the end of the century, but limiting warming to 1.5 degrees is vital. Evidence shows that temperature increases of 2 degrees, only half a degree more, would lead to a total loss of coral reefs and twice the loss of biodiversity. The human costs would also be staggering. Poverty rates would triple, and human health outcomes would degrade. When we moderately cut down on fossil fuels like coal, oil, and gas, global temperature increase reduces to 3.4 degrees Celsius. Using renewable energy sources and putting a price on carbon could help bring the projected global temperature increases down to 2.8 degrees Celsius. Further reductions to 2.3 Celsius are projected if energy efficiency and electrification are encouraged in transport in buildings and industry. Only limiting land and industry emissions help reduce the global temperature increase to 1.5 Celsius, which is by far the largest change. They do this by encouraging afforestation, alleviating deforestation, and reducing greenhouse gas emissions, including methane, and also by practicing technological carbon removal processes. Limiting our temperature increase to 1.5 Celsius is what's recommended by the IPCC, and it seems achievable according to the simulation tool developed by MIT and Climate Interactive. Electric vehicles have a much lower climate impact than traditional gasoline cars. More and more Americans are becoming interested in purchasing an electric car as their next vehicle. In order for these cars to dominate the market, we need to invest in infrastructure to support them. Broadening our network of fast charging stations and standardizing the plugs used for charging would make electric cars more accessible to a broader range of people. It would also make it easier to take extended road trips, relying solely on electric power. Promoting increased usage of electric vehicles would also make society less dependent on fossil fuels. While we still have a long way to go, we already have some success stories that we should use as our motivation to keep pushing forward.
Just 1 year before the Paris Agreement, solar and wind electricity was cheaper than fossil electricity in only 1% of the world. 5 years later, 2/3 of the world. 3 years from now, it will be the cheapest source in 100% of the world.
And now there's a growing universe of satellites designed to locate and measure methane from space. That list includes MethaneSat, which is expected to be launch ready next year and will be able to detect and quantify methane emissions across the globe with unprecedented precision. If we can find it, we can fix it. This part is not rocket science. It's more like plumbing. I can't tell you enough how hopeful that makes me for the future.
That's why the industry is so focused on innovating and scaling to lower the component cost of EV batteries, and it's working. In 2013, the average price per kilowatt hour of an EV battery was $668, meaning the base model Tesla Model 3's 50 kilowatt hour battery would cost $22,400, 2/3 of what the vehicle sells for. Nowadays, the average price per kilowatt hour is all the way down to $137, meaning that same battery pack would cost just $6,850, and this price per kilowatt hour is expected to lower to $100 by 2023.
In addition to our achievements, we also have plans to keep up the momentum. For example, China has pledged to meet net zero carbon by 2060. The EU has pledged a new 55% greenhouse gas reduction by 2030. And the ozone hole is slowly being repaired. We have shown you what issues we are currently facing, and what may lie in wait for us if we refuse to make any changes. But we have also shown you there is reason to hope. The first step to securing our future is the hardest, but we've already taken it.
Now, do you still remember the poor boy? Luckily, his sadness didn't last for too long. He decided to finish all his work and go to bed early this time, and maybe his lovely girl would give him a second chance. Earth might want to give us a second chance too.